Hello everyone, my name is Yihan Lin, and I'm gonna do the question 2 of homework 6, so let's begin. So for the subproblem A, it tells to find B so that the above defined function is a valid joint possibility density function. So we know that it is a valid density function only and if only this integral over this area, that fxy xy dx dy equals to 1. And we know that this joint density function actually equals to b, which is a constant. So we only have to know this side of this area d, and this area is x squared plus y squared is smaller or equal to 1, so it's just a circle whose radius is actually 1, so the size of this area is pi times the square of r, and r is 1, so it's pi. So we know that this integral equals to b pi, so we have b times pi equals to 1, and obviously we have b equals to 1 over pi. So that's the value of b. And for the subproblem b, it has to find a lot of expectation, obviously. So we first calculate the expectation of x, and based on the theorem, we know that this expectation of x equals to the integral over this area x, fxy, the joint density function, and dx dy. So it equals to, we can put the integral of y inside and let the integral of x outside. And inside, we have y is from minus square root of 1 minus x squared from to the square root of 1 minus x squared. And outside, the x range is from minus 1 to 1. So we calculated it. Inside it will be x times square root of 1 minus x squared, and we simply calculate this integral of x is equal to 0 because obviously square root of 1 minus x squared is an even function, and x is an odd function, and an odd function times an even function is still an odd function. So the inside is an odd function, so the integral over an odd function from minus 1 to 1 obviously is 0. So the expectation of x equals to 0. And then we'll calculate the expectation of x under the condition of y. So first we calculate the density function of y, and based on the definition, if y's range is from minus, we calculate the integral of density function over with respect of x dx, and the range is from minus square root of 1 minus y squared to the square root of 1 minus y squared, and this result is 2 over pi times the square root of 1 minus y squared, and obviously the range of y is actually the absolute value need to smaller or equal to 1. And then we calculate the probability of x under the condition of y. That's the function of it. So based on the definition, the fx under the condition y equals to the joint density function over the marginal density function of y. So the joint density function is 1 over pi, and the marginal density function is 2 over pi times the square root of 1 minus y squared. So it equals to 1 over 2 times the square root of 1 minus y squared. Then we'll calculate the expectation of x under the condition of y based on the definition. The still integral from minus square root of 1 minus y squared to the square root of 1 minus y squared. Inside is x times the conditional density function, dx, and it's 0 because we know that the this conditional density function is actually it's actually a constant with respect to x. It's not related to x. So we have this x as an order function. So the inside this fxy and condition y is actually an order function. So this integral is actually equals to 0. And because we know that the so we have the expectation of x and the condition of the y, and here y is a random variable, it's also equals to 0. And because we know x and y are actually symmetric with this joint density function, it's actually constant. So either way x and y are symmetric. So we know that equally expectation of y and expectation of y and the condition of x and expectation of y and the condition of random variable x, is all of this equals to 0. And then finally we need to calculate this expectation of xy, and just based on the definition is equals to the integral over this area x times y times this joint density function dx dy. And we just calculate it. It's actually also equals to 0. You can just directly calculate it, or you can just use the order function to prove it. Either way, it's equals to 0. So for the subproblem C, it tells to prove or disprove x and y are uncorrelated or not. So we know that based on the result of B, we have EXY equals to EXEY. Actually, all of them are 0, so we know x and y are uncorrelated. So that's all for the subproblem. That's all for the question 2. Thank you.